Good morning or good afternoon to everyone, wherever you might be. I'm Lance Roberts from the National Adult Day Services Association, and welcome to today's webinar. Before I turn things over to Dr. Warlow, I just wanted to go over a couple of items. Everyone will receive a copy of the presentation, and they will also receive a link to the audio recording that we're doing as part of the webinar. And if you would all write your questions in the question box, we will take those at the end of the presentation and try to get to as many of those as we can. So with that out of the way, Dr. Warlow, the stage is yours.
Well, thank you so much, Lance, and good afternoon, everyone. And thank you for the opportunity to discuss a topic about which we have been focused on, passionate for years, if not decades, air quality, but more importantly, the control and comprehensive remediation of air quality because of its impact that we've learned it has on patient care, resident, client, and staff wellness. As a healthcare-centric technology company focused on improved patient care and wellness, we are driven by outcome data and robust clinical trials. To this end, I'd also look forward to sharing with you the key take-home messages learned from two very large clinical studies in healthcare and senior living, the results of which truly offer a paradigm shift, if you will, in air purification and wellness. So as an overview, I'd like to discuss the significance, what we have learned, the take-home messages of the significance of air quality to staff and adult day client wellness, what technologies are available today, and most importantly, understand what they deliver and what they do not deliver. There are a lot of claims, but what's absolutely critical is to understand the data and support and proof behind those claims. And then, as I shared, we'd like to discuss the take-home messages and results from two very large clinical IRB-approved studies in healthcare and senior living, involving over 8,300 adults over a 12 and 15-month course of data collection. And then the clinical and economic impact of using a specialized air purification system, a very aggressive and comprehensive air purification system in senior living and care, and its impact on census and reduced operational cost. So why are we discussing air quality today and airborne transmission? It's interesting to note these first two bullets are actually from the CDC, and they really are not well known or understood. The fact that 69 to 80% of the pathogens that cause illness, very common illnesses and infections, 69 to 80% of the pathogens that cause these illnesses are airborne. Secondly, greater than 90% of all of your infectious surface pathogens originate from the air. So we're all focused on cleaning the surfaces, which no one should stop. All infection control protocols are typically surface oriented, but to consider that 90% of what lands on the surface comes from the air, and that such a high percentage of pathogens that cause illness are airborne, this is the issue we're really going to focus on today. Third, conventional capture filtration with standard MERV filters, HEPA filtration, does not provide comprehensive remediation of all airborne infectious pathogens. And infection control and cleaning protocols, although everyone is doing a phenomenal job, especially in this last year and going forward, that's not eliminating the problem of preventing or reducing illness or infections acquired in the senior living facilities and in those environments. And finally, a point that also is not well understood is that air quality is very dynamic. Your staff, your clients, and we'll get into the details of this, but your staff, clients, and activities are constantly adding to the viral and bacterial and fungal load in that space. For the last over a year, we've all been quite focused on what we've learned is COVID-19 or SARS-CoV-2, very infectious virus that has changed our lives forever. And we will get through this. But what we try to emphasize is for people, which is what our focus has always been, is not just focus on remediation for COVID-19, but also some of the more common and persistent airborne viruses and bacteria that have been with us for some time and will probably continue to be with us, as well as new variants that will be generated from the current COVID-19. Relative to COVID-19, it's a very small virus, actually only 0.12 microns across the diameter of the virus. Your typical HEPA filter will capture by size, obviously, and it'll capture particulates that are 0.3 microns or larger, or it'll be the most effective on those viral particles that are 0.3 microns or larger. Comparing the COVID-19 viral particulate to the human hair, it's actually 142 to 1,500 times larger. Or the COVID-19 is actually smaller by that degree from the human hair. And then, of course, for any sports fans, the typical baseball is over 6 million times larger than the COVID-19 viral particle. So it's a very small virus. It's actually very similar to influenza as well as far as size. When you think about the airborne transmission, now this data is specific to the original COVID-19. Unfortunately, the variants that are now in existence are far more infectious, but relative to the original COVID-19, you only need to ingest or to be exposed to 1,000 viral particles to be infected. So that could be one breath of someone who's infected, just one breath of 1,000 particles, 10 breaths of 100. Our exposure can be allowed by an infected space in a building, an elevator, a restroom, just by rubbing your eye, your mouth, the nasal rub. I mean, in addition to protecting us in many ways, the mask also prevent us from, touching our nose and our mouth, et cetera, which is an added benefit. And these COVID-19 viral particles can actually remain viable for several hours within the air. So if there's someone infected within a space and they're breathing, speaking, singing, their infectious viral particles will remain viable for several hours within that space. If you look at the literature and break it down by typical activities, breathing releases the fewest. I put these in order of the fewest infectious particles to the greatest. So just by breathing, if someone's infected and you're just standing beside them and they're breathing, you can actually be infected in about 50 minutes, because by breathing, we release 3 to 20 viral RNA copies, which are the infectious part of COVID-19. Now, these particulates are a very low velocity, and they do fall to the ground typically within 6 feet, which is primarily where the 6-foot social distancing comes from. But if someone is speaking to you, singing, or shouting, they actually could be releasing 200 viral RNA copies, again, the infectious piece of this virus. They could be releasing 200 per minute, infecting others in 5 minutes. Now, these have a far greater velocity and can travel up to 15 feet. If someone coughs, you can release 3,000 droplets, and these droplets can actually have a velocity of 50 miles per hour and can travel up to 19 feet. Flushing the toilet, you've probably heard of a number of universities actually analyzing the waste or the sewage from particular dorms to identify whether or not there's a COVID positive student within particular dorms, because they have found viable viral RNA in fecal material. But just flushing the toilet can generate a toilet plume, as they call it, of 8,000 infectious droplets. Sneezing, obviously, releasing the greatest number, up to 30,000 per sneeze. These can travel at 200 miles per hour and up to 26 feet. So we've mentioned that within the air, the virus can survive for up to 3 hours. On surfaces, for example, I've tried to list the most common surfaces. On wood and cardboard, they can survive up to a day. Cloth, glass, 2 days. Steel and plastic, up to 7. So the surface cleaning is obviously paramount, but again, reducing airborne loading is critical. So which is why we wanted to talk about how best to comprehensively remediate the air, serving the spaces in which we live, in which we work, in which we serve others. So what's available today? There are a number of older technologies that have come back to the surface. For example, there are a large number of in-room units, many using slightly different technologies. But they all have one thing in common, in that they filter the pathogens once the pathogens are already in the space. So the pathogens are therefore already a threat to the occupants. So because the in-room unit is not filtering the air entering the space through the HVAC system, you can have infectious pathogens enter the space you're trying to protect via the ductwork or the air handler in your building. And again, the staff, visitors, the clients, the activities continuously add to the viral and bacterial loading in the air. We just talked about breathing, speaking, singing, sneezing, coughing, flushing toilets. It's a very dynamic number as to what the level of air quality is, what is the viral and bacterial loading in that space because of the continuous contribution. There are a number of studies that demonstrate varying in-room technologies could take up to 60 minutes to actually remediate COVID-19 comprehensively. And a lot of these tests are done in a sealed test chamber or a sealed test environment where they'll fill the chamber with an active virus and then place the technology within that space and then monitor the decay of that virus. So they can actually require up to 30 to 60 minutes to remediate COVID-19 and other viruses. But as we've discussed, if you're just speaking to someone for 5 minutes and they're infected, you too could become infected. Finally, the in-room unit can only move a small volume of air. It can't comprehensively protect all area in larger spaces, and most use your capture filtration, your MERV or your HEPAs, which will capture a number of the viruses, bacteria, and fungi. However, they're not killed. So they continue to grow on that filter in the in-room unit in the space that you're trying to protect. Standard UV light. UV is not a new technology, and it's been adequately proven to kill not only COVID-19, but other viruses. But I'm going to jump ahead to this last bullet. All UV is not created equal. What I mean by that is for UV to be completely effective, you need to consider and model all of the HVAC metrics. So the ductwork, the size of the ductwork, the course of the ductwork, the air handler, the space you're trying to protect, the air velocity. All of these must be modeled to develop a proper or to ensure a proper kill of your targeted infectious organisms. You need to consider the wavelength, the intensity of the UV, proper sizing of the space. What is the reflectivity? What is the exposure and dwell time of the air to the UV light? And then what is the proper configuration and positioning within the ductwork? So again, all of this must be considered to properly protect yourself using this technology. MERV and HEPA filtration. MERV filters are rated anywhere from 1 to 16, 16 typically being the highest or the best level. To give you an example, schools and commercial office spaces typically use a MERV 8 or 9. HEPA is typically a MERV 17 and provides the 99.97% filtration, again, of pathogens greater than 0.3 microns in size. I hear a little echo in the background. Background noise, I don't know if everyone's muted. Lance, I don't know if you hear that. All right, I'll continue. And again, as we said, the HEPA filtration will filter out pathogens greater than 0.3 microns. COVID-19, influenza, and other common infectious viruses are smaller than this and therefore can pass through MERV and HEPA filtration. They're not captured at 100% levels. And as we mentioned, anything that's trapped or captured can continue to grow on the filters. And we'll discuss that in a little further detail. And finally, per ASHRAE, which is the governing board really of indoor air quality and ventilation in really all spaces, HEPA filters do add a significant pressure drop. And so if you're looking at retrofitting an air purification solution, this can add a strain to the existing air handler. It may require an upgrade of the air handler, which is an expense. So you need to consider the value of the HEPA filter versus what is necessary to install it, especially if it's an older infrastructure with existing air handlers. So if you think about the typical capture filter or HEPA filter, again, it's going to capture things based upon size. So these organics that it's capturing can continue to grow. They need two things to grow, food and water. Food is often the other organics, and water can be the humidity in the air. And again, all of your chemical pathogens are going to go right through, as well as some of your smaller viruses and bacteria, as well as fungal cells that are shedding, which leads me to this slide. This is in the ductwork, and sadly, we see this far too often. This is in the ductwork after the HEPA filter, en route to the space that you're trying to protect. In sampling some of this, these are Aspergillus fungal spores, which can be a significant cause. It's a very common cause of illness. And so these Aspergillus spores typically are large enough for a HEPA filter to capture. But what happens with a lot of fungal spores is individual cells will shed and pass through or around the HEPA filter. So again, you know, those working in the space after you go through around this ductwork, assume that they're protected by the HEPA filtration, but yet their ductwork is lined with Aspergillus fungal spores, again, which is a very common source of illness. Photocatalytic oxidation, or PCO, again, not a new technology. It's another form of UV light. It uses a catalyst. Catalysts degrade over time. So as the catalyst degrades, the effectiveness of the technology degrades, which is one reason we chose not to develop a technology that incorporates the catalyst.
You have entered as an attendee in listen-only mode.
PCO can also generate byproducts. And from the studies, again, in a sealed environment, not a real-world situation, it requires a longer exposure time for effective remediation. You've probably heard a lot about bipolar or needlepoint ionization. Again, not a new technology, but it basically uses charged ion that combine with different particles in the air to neutralize or kill the particles. And again, this requires final filtration to capture the charged particles. It's considered an emerging technology, but does not deliver on a single pass. And we'll discuss this further, what we mean by delivering or killing on a single pass. And again, to achieve greater than 99% kill of COVID, it requires 30 to 60 minutes of exposure time. Per ASHRAE, this technology is actually only 20 to 30% more effective than the natural decay of pathogens. And again, when any of these technologies are making claims, you want to make sure that there's been a rigorous peer-reviewed study of effectiveness. How are they making those claims? How did they test it? Where is the body of evidence? It's very, very important. And also make sure that by achieving certain remediation, it's not producing harmful ozone, carbon dioxide, or other byproducts. So in addition to being driven and really focused on improved patient care and resident, staff, and client wellness, we are absolutely driven by data. So we have conducted very large, again, as I said, IRB approved clinical trials in healthcare and senior living, as well as studies with the National Homeland Security Research Center to prove and document the effectiveness of the technology that's involved in the LifeAire system. So I'll explain the genesis of our technology towards the end of our discussion, but it's really because of our genesis and where we came from that drove the design criteria of our air purification technology. For example, we chose to, one of our goals was to kill the anthrax spore. Fortunately, not because we were concerned about the anthrax spore, but because it's one of the hardest airborne pathogens to kill. And this data is not ours. The anthrax kill was verified by National Homeland Security Research Center. And because of the kill of the anthrax spore, we provide a significant and comprehensive kill of the airborne bacteria, viruses, and fungi with which we are more concerned, which are highly infectious. Another key point is that this kill, and again, we wanted to stay away from capture because we didn't want viable viruses, bacteria, and fungi growing on a filter within our system. So we're very focused on penetrating the cell wall of the infectious cell and destroying the RNA and DNA, rendering them completely non-infectious. Our technology is not only backed with peer-reviewed studies and publications. We now have 28 patents, other patents currently being reviewed. And this work comes from over 20 years of research of the impact of, particular aspects of air quality on patient and resident care. We're fortunate to be installed in over 50 leading healthcare networks. And finally, one piece that we truly enjoy, our engineers and team perform custom analyses. There is no one solution that fits all. So we perform custom analyses to look at all aspects of the HVAC system, existing old infrastructure, older air handlers, the size of the ductwork, the air velocity, the reflectivity, what other constraints could be in place above the ceiling. Perhaps there's no room above the ceiling. You have to look at everything to come up with a solution where you can ensure that not only COVID-19, but all other infectious pathogens are going to be killed. And again, I'm going to use this word again, it's very important, in a single pass. So why do we emphasize this? If you look at the right diagram, so our system basically replaces ductwork or fits within the ductwork, depending upon which solution you're looking at. So when we say killed on a single pass, what we mean is that any infectious virus, bacteria, fungi, chemical pathogen that enters our system is not going to exit. Single pass kill, very important. You don't want the air to have to go through the technology 5, 10, 20, 50 times so that you can be assured of what exits the diffuser or what exits the in-room unit is devoid of these infectious particles. And that was our goal, so that we know it's also a constant kill 24/7, so you don't need to vacate the room during occupancy, because again, each individual entering the space, whether they're coughing, talking, sneezing, breathing, activities, everyone adds to the viral load, whether you're infected or not. And so that viral load is very dynamic, and that's why we wanted all recirculated air to go through our system and exit without any infectious particles. When the National Homeland Security Center tested our technology for its kill against anthrax, again, because of the 99% kill of the anthrax spore, We actually provide a 9 log reduction, 6 log of sterility, so a comprehensive kill of the more common infectious bacterial spores, as well as the more common infectious viral spores, including obviously COVID-19. And again, a number of these viruses are smaller than the 0.3 microns that the HEPA filter, where it really is the most effective. Now, we talked earlier about 2 large totally independent IRB approved clinical trials, one in a healthcare setting, the other in senior living, involving over 8,300 adults over a 12 and 15-month period. Relative to the senior living study, there were 2 floors, very similar etiology for the residents. Each had their own air handler, and each had HEPA filtration after the air handler. On the one floor, we added the LifeAire technology to protect the entire area, the community area, the dining area, the corridors, the administrative station, the resident rooms, and then compared not only environmental data, but clinical and economic data to the floor immediately below, and again, similar etiology senior residents. This is an image of the system. This was particularly an all-weather unit that was retrofitted to serve that entire floor. We conducted the most comprehensive airborne and surface testing that can be done to date in all areas of this floor, the resident rooms, the restrooms. You can see the surface swabbing here. Let me go back a slide. The airborne sampling is done by something called an Anderson pump sampler. I enlarged it here. Basically, air is pulled through the sampler onto a blood agar plate. The blood agar plate is selected to promote the growth, to cover, a wide spectrum of bacteria, a wide spectrum of fungi. So when we get the results back from the independent laboratory, it's a third-party, very well-respected industrial hygienist laboratory. They do worldwide testing. When we get the data back from them, they tell us not only the species of bacteria and fungi in that space, but the concentration. So a tremendous amount of information relative to that space. So again, we did airborne sampling as well as surface sampling in multiple areas throughout this space. They had 2 community rooms on this floor where they did quite a few activities on an ongoing basis. The dining area, again, here's your Anderson pump sampler, also did swabbing. We swabbed some of your more commonly used equipment like dining carts, the counter desktop of the administrative area, the hallway corridor, and again, many, many more areas that were sampled. And our goal was, this particular senior living facility shared with us their experience on the most common environmental illnesses, and these are all caused by airborne pathogens. So our goal on that particular floor, protected by our technology, was to completely remove these from the airborne environment. So the results, again, we probably have 50 slides. I'm only going to show you one, but we're happy to share more information if anyone wants greater details. And much of this data has been submitted for publication as well. But we're happy to share more details if anyone would like to discuss that further. But just in general, this is looking at total airborne viable pathogen loading. So these are living bacteria, living fungi in each of these spaces. Before, this is HEPA protection, LifeAire protection in each of these various areas along that floor. Also interesting, on the control floor, not protected by the LifeAire technology, the senior living facility shared with us their microbiological data. So there were residents and some staff that when they became ill, to properly treat them, they would culture to identify which pathogen was causing the illness. So this is it's actually a short list of some of the infectious pathogens that were cultured from ill residents or staff on the control floor. And this is a fairly typical list in senior living as well as adult day that are fairly common. But as you can see in red, we put in red those that are airborne. And again, none of these bacteria or fungi were present on the floor that was protected by the LifeAire technology. But being present in the air or on the surface allowed these illnesses on the control floor. So in summary of this particular study, and again, this was a 15-month study, there was a 99% reduction in airborne pathogens in the space protected by the technology, which resulted in a 96% reduction in surface pathogens. Remember, per the CDC, 90% of what lands on the surface comes from the air. And this is exactly what we saw in both studies. You completely remove your airborne viral and bacterial and fungal loading, you dramatically reduce what's on the surface. So by removing two common sources of illness, two common sources of infection, air and surface, the clinical results have been dramatic. In the senior living facility, they realized a 39% reduction in facility-acquired infections as compared to the control HEPA-protected floor. And this was significant. Just client wellness. It also transposed to staff wellness. In all honesty, we were not tracking this metric, but they shared this with us. There was a 47% reduction in staff callouts or staff illnesses, which was tremendous for them because then, I mean, the staff know their clients the best. And this way, you know, they wouldn't have to use a third-party provider of staff to supplement those, you know, while they were out ill. So this was also significant to them. It also helped allow them a safe reopening, given what we're all going through now, but yet more importantly, ongoing protection. Again, we will get through COVID-19, but ongoing protection from the viruses that are more common and probably with us for some time, as well as variants that are now mutating and forming. It allows them to differentiate themselves among the market to clients, providers, and payers, reducing citations for infection breakouts that are reported, and then realizing increased referrals from healthcare network providers and maintaining that 5-star status. I mentioned earlier that the genesis of our technology is really as unique as its impact on the environment, patient care, and wellness. And what I mean by that is our genesis actually began in our desire to protect the living cell, in our case, the human embryo, that's grown outside the body for up to 6 days. So I was blessed with a career as a clinical provider in human in vitro fertilization, and we learned over a 20-year period the significance of airborne pathogens that are very common to IVF laboratories, but the significance of airborne pathogens on our ability to successfully grow the human embryo outside the body. And once we learn the significance of the air quality metrics, we searched to purchase something commercially, and there was nothing available that would deliver the metrics we knew we needed. And that was the genesis of LifeAire. Because we were trying to protect the human embryo, we set the design bar very high of what we wanted this air purification system to deliver. And it's really offered a technological paradigm and shift in how we view air purification. Our design criteria, again, we did not want it in the space. We wanted it in the ductwork. because we wanted it to purify all outside source air, which you will never control your neighbors and what they do. Again, we learned that the hard way, as well as all recirculated air. As staff, as clients, as patients, as activities, again, we are generating a lot of the airborne pathogens. So we wanted all return air as well as all outside source air to go through the system. We wanted to deliver 100% effectiveness, again, on a single pass through the system. What enters does not leave. We wanted this technology to deliver without producing byproducts, ozone, or intermediate molecules. We did not want to use catalyst because, again, as catalysts decline, as they degrade, so will the effectiveness of your air purification technology. It was very important to us before we launched or shared this technology with anyone that we have robust, solid, peer-reviewed clinical trials to prove the effectiveness of the system, the absence of byproducts, and the impact clinically on wellness and on the economics. Our goal was to drive bacteria, fungi, viruses, and your chemical pathogens to zero, meaning you're completely removing that vector of illness. Airborne viral loading, airborne bacteria and fungal loading, you're driving that vector of illness to zero. Again, the system was tested by National Homeland Security for its kill against anthrax, and the technology involves genomic and mathematical modeling of all bacteria, viruses, and fungi so that we know we're providing adequate kill. And finally, if you're able to kill the anthrax spore, you do provide a significant reduction, comprehensive removal of the more infectious pathogens with which we are concerned. We're fortunate that our installed base includes really leading medical centers within the United States, and they also are our ongoing technology and scientific partners in publishing their outcome data together. And the genesis of our technology, as I said, began with human in vitro fertilization. But knowing that we had a proven technology and proven in real world healthcare and senior living settings, and wanting to help provide protection to non-healthcare spaces, given our current circumstances, we've developed solutions to deliver single pass kill of not only COVID, but also other common bacteria and viruses to protect a variety of spaces. Again, providing single pass kill where a unit could just be inserted within the ductwork to deliver this level of protection. But solutions that could protect large common spaces or community areas, dining areas, individual activity rooms, restrooms, offices, solutions that could be retrofitted into an older infrastructure, provide minimal strain on your existing air handler so that you don't incur additional cost, and to be able to deal with a number of constraints or even the absence of any space right above the ceilings. And again, this solution has to provide a kill on a continuous and rapid remediation, single pass, because there's a lot of traffic in and out of the areas that we're discussing in adult day programs. And again, breathing, talking, coughing, sneezing, activities, all of these very typical activities within these spaces are going to continually add to the infectious loading within that room. So our goal was to help in any way that we could with a proven technology, provide protection, allow safe reopening, improve census, reduce staff sick days, which has been proven by the larger study, maintain client wellness, again, proven by the larger study, and offer customized solutions. There is no one solution that fits all spaces. Every metric, every HVAC metric and space metric must be considered so that you're telling that end user or the owner of that adult day program, this solution in this space is going to provide a comprehensive kill of not only COVID, but your other more common infectious pathogens today and going forward. Two of these solutions are what we call the Air Bio Lite and Air Bio Mid, again, delivering on a single pass. We can accommodate smaller sizes as well as much larger sizes. And again, it's all in the modeling that our engineers provide. So really, in summary, the technology began in protecting the living cell grown outside the body for up to 6 days, the human embryo. And once we realized the significance of airborne pathogens on our ability to deliver the highest level of patient care, and realized there was nothing we could purchase to remove this variable, this negative, very negative variable from our process, the LifeAire system was designed. And because we began in human IVF, the design bar was set exceptionally high, which then led us for applications within healthcare and now senior living and adult day programs. And our goal is 99% reduction of your airborne loading, therefore reducing your surface loading. These are the two studies I was referring to. We had reduction in HAIs in the clinical setting, a 39% reduction in facility-acquired infections in senior living, and again, 47% reduction in staff call-outs. Very similar results in two very different clinical settings. So at this point, I'm happy to go back to any slide, address any clarifying questions. Look forward to continuing our conversations. And I thank you for your time.
Dr. Warlow, thank you so much for such an informative presentation. As folks start to gather their thoughts and questions, I'd like to share some of the ones that have already been written down. One of which is, what in your system kills the viruses? Is it something physical or chemical?
It is something physical. It is not chemical. So it does involve some UVC, but again, it involves many, many other metrics that have to be considered so that you know you're penetrating the cell wall of the infectious pathogen and completely destroying the RNA and DNA.
Another question, and this may seem somewhat obvious, but obviously the system kills a wide range of pathogens. How does it treat things that are more common in facilities like dusts and molds and pollens, other sort of more naturally occurring types of elements that can still lead to, while not as severe of an illness as what COVID-19 does, but illnesses that still affect both the people who are the participants in a center as well as the staff?
Yeah, that's a good question. So fungal mold, as you asked, mold and fungal spores are actually not that easy to kill. But our system does the same thing to mold as it does to viruses and bacteria. It destroys the genetic components of that mold, so that's completely non-infectious. So that the mold is completely dealt with in the system. Dust, our system does come with a final filter if that's required, but you don't need, if your air handler has a final filter, which most do, that we can probably evaluate that and perhaps upgrade that filter if dust is an issue, or we can just add a filter to our system, but you don't need both. You just need either one on the air handler or one on our system. And again, you want to keep the strain on the HVAC system to a minimum.
Looking at the making sure your surfaces are clean, certainly the system assists with a great deal of that, but to, I guess, ensure that all systems are clean, someone's asking, what do you all recommend in the way of effective cleaners? Is it Lysol, Clorox wipes? what do you all see as effective sort of secondary cleaning products?
I mean, I think we're very air centric, but I think, you know, adequate cleaning products, you know, the Clorox wipes, you know, the Lysol sprays. You also need to make sure, you know, that it's not going to, you need to clean and kill what's on the surface, but you also want to be thoughtful of, you know, some clients may be sensitive to some of those chemicals. So probably the best time, you know, to clean is when there are fewer people in the space, but the Clorox wipes, you know, the Lysol, of course, 70% alcohol works as well, 70% isopropyl alcohol, but that can leave significant off-gassing behind. So it's often a balance of providing that the cleanliness, but considering, you know, those who are in the space as well.
And I know you know the answer to this question from our previous conversations, but I'm glad someone has asked it. Is this product adaptable on a smaller scale for a person's private home?
Yes, I actually have it in our home. It's the units that I showed. Whoops, let me see if I can go back. The units that I showed, these two units, we actually have this one in our home. So you again, you want to model it to do it the right way. But we just have this on the return side, entering our furnace. And we have a very typical, you know, HVAC system in our home. There's nothing special about it, but we wanted to add this level of protection. But we do have it in other homes as well. And again, we really, you know, are offering these solutions to offer, you know, just protection for your non-healthcare spaces, whether it's a commercial office building or adult day or dental practices. I mean, our goal was just, we're all about patient care and wellness. So we wanted to pivot using what was already proven and known to work.
Does this actually, and I'm going to assume the answer is going to be yes, if you were to use it in your home, it would help with things like allergens and, you know, cleaner air in your home. There's probably a use for that, correct?
Yes, it does. Yes, it's not picky about what it kills. It's going to remove a lot of the pathogens that cause allergens, you know, the fungal spores and, you know, obviously the viruses we're concerned with. But again, you need to think past COVID because we will get through this. But we want, if anyone's using our solution, we want to make sure they're protected for the going forward.
So basically anything new that could come up, or like the, I guess they're called the COVID variants.
Mm-hmm. Yes.
So they would be useful for the variants as well.
Oh, absolutely. Absolutely. It's all about it's all about the amino acid sequence of the virus. And so that's why when I say our technology is genomically modeled, it's looking at that amino acid sequence of each virus so that we know it's going to be destroyed.
Dr. Worrell, in looking at the installation aspect, and obviously a lot has to depend on the type of existing HVAC system there is, the building. So without getting too deep in the details of every possible scenario, because obviously there are hundreds, if not thousands of them, depending on the building, but generally speaking, installing a LifeAire system, does that require extensive HVAC work or replacement? And then more on the inside of the building, how many are needed? Would there be one for, say, every duct in a space? Even using the example of the controlled versus the LifeAire system in the one study that you shared with us, how would it compare, I guess, in that particular system?
So in the study, it was actually one system that protected the entire floor. So Again, it all starts with, I'll show this image, it all starts with the size of the space, the cubic volume of air that you're trying to protect. So for example, the senior living study, our engineers sized that entire floor. So we knew how much cubic volume of air we needed to purify. That's the starting point. And then we look at their air handler, we look at their duct work, we really look at everything that's going to contribute to that environment and try to offer them the most seamless and most cost-effective LifeAire solution, whether it be, you know, the full system that was in the senior living study or the smaller units. The full system basically replaces ductwork, and it's always downstream of your air handler. But then again, we have the smaller solutions, which I don't know why that bell keeps going. Smaller solutions that literally you just cut a hole in the ductwork and insert it inside. So it doesn't replace the ductwork. It's actually very easy. It's very plug and play, and just you insert it into the ductwork, both of these. And the BioLights and the BioMids, you asked, is it one per ductwork? Again, it's all about our engineers look at all of the metrics, and you may just need one unit for a space, or you may need 3 for a space. It all depends on the height of the ceilings, the air changes per hour, and the layout of what you have. But our goal is to keep installation cost as minimal as possible and to put as little strain on your existing infrastructure as possible. Our goal is this, to provide the protection and the kill on a single pass.
Kind of dovetailing on that question, with regard to installation, and again, I understand it really depends on, you know, the room or the building, but generally speaking, if say a standard size adult day center wanted to have a system installed, what type of, I guess, time element does it usually take to install a system? Would they have to close, say, for a week or a few days? Could it be done over a weekend? And again, just in general, since obviously every situation would be unique, but just to give those listening a time frame sense of what a LifeAire system installation might entail, depending again on the size of the building and the space.
It actually, whether it's it depends on which system it is, but these units, literally hours, and you could do it over a weekend. The larger unit that was involved in the study, that unit required 4 hours of installation at the hospital. So it really depends upon which solution, but these smaller ones, it's just a matter of literally hours.
Going back to home-based systems versus commercial systems, someone's asking if this can be installed with a hot air HVAC system in a private home that just has radiators and wants to catch allergens.
So that sounds like there isn't ductwork. So if there's not ductwork, we need ductwork. If there's not ductwork, then because all of this is it either replaces the ductwork or it's inserted into the ductwork. So if that hot air and radiator heat doesn't use ductwork, then this probably would not be an application.
Now, LifeAire is available nationally, correct? You all are installing these across the country.
We are, and we actually also received our CE certification. So we're working with European colleagues now as well, and we also have units in Canada.
A couple more questions since we're closing in on our 1 hour time frame. Can people be in the room while the unit is on? And I would assume that the air purification could encompass an entire facility if necessary, if you know that's what someone asked to have installed.
Yes, the unit that was part of our design goals of the technology is we did not want you to have to vacate the room. We never want to lose use of the space. So you can absolutely be present while the unit is on. In fact, we recommend you never turn it off. There are no byproducts at all formed from this. So it's completely safe to be in that space while it's operational.
Okay, I don't see any more questions. Dr. Worrell, any final thoughts you'd like to offer before we close out your presentation today?
No, Lance, I just really appreciate the opportunity. Like I said, we're very data driven, and we're just thrilled with the studies. And as I said, we're submitting the publications, the data for publication as we speak. And I just thank you for the opportunity to share the technology and the data with everyone.
We do appreciate that. One last question has popped up, and I think this is one that I think probably is in the back of the minds of everyone. What is the noise level of the system as it's running? Is it any different than a normal HVAC system when it's running? Does the installation of the equipment affect that sound in any way?
No, the noise is minimal. In fact, we actually have a very large system installed above a massage room. It's not protecting the massage room, it's protecting another space, but the unit is actually installed right above a massage room, and there have been zero complaints. The noise is nominal.
Well, again, Dr. Worrell, thank you so much for taking the time to put this together, and I know the audience certainly appreciates not only learning about the LifeAire system, but all the other aspects of air purification that you brought up, and some of the nuances of how different systems work and how effective certain filters can and cannot be in taking care of these very dangerous pathogens that can be so impactful on especially folks who are in adult day because of their age and possible physical vulnerability. So thank you very much again. And I just want to remind everyone, we will be sharing the presentation and the audio link from today's presentation in the next day or two, so that you'll have access to it and can refer back to it if you have any questions. So thank you everyone for attending. We really appreciate your time today. Please stay well and stay safe, and hopefully all of us will be out of this COVID situation in the very near future. You all have a great day.
Thank you.